right, so today we're going to continue with object-oriented programming. The last pillar today, which we'll go into a demonstration on Friday. The last pillar being polymorphism. Remember, the first two pillars were basically complements of each other, where you have abstraction and encapsulation working together. And then you have this new idea of inheritance, where you can subclass stuff. Polymorphism is even cooler than all of those things combined, at least in my opinion. So first of all, the term polymorphism comes from biology. Those of you with Latin experience, tell me what polymorphism means. Polymorph, just the word itself. So poly is many, all right? And what is a morph? A change. But to change, you have to start in one of these and then go into a different one. They are forms, right? Many forms. I'll go ahead and put that into parentheses there, right? I think that in the context of biology, correct me if I'm wrong, any biology, life sciences 101 folks, but a polymorph refers to phenotypes. So for example, a tiger can be striped, or it can be a solid color, or it can be something different, right? Those are the phenotypes, so those are the small differences within a population, within a same species or the same order or something like that. And that's what polymorphism is, right? In the context of code, it means that a variable, a method, or a class in Java can be generically programmed so that it can be applied to more than one type or many different types, right? You've seen this before in, say, C. It's just that it wasn't strong polymorphism. For example, how did we sort? Right. Did we write a sorting algorithm and a sorting function? Was there a sorting function for an array of integers, and a sorting function for an array of doubles, and a sorting array function for strings? Right. No, there was one sorting algorithm. What was it? We used qsort, right, which took any type of variable. What about in, well, here, Python. How did we do it earlier in this semester in Python? Right. We use what? Sort or sorted, if you wanted a sorted copy, right? Which took, guess what? Any type of variable. In Java, we have even stronger, right? Java has static typing, right? And so, come on, really? Everybody's internet is okay? It's starting to degrade over here. All right, hopefully we're fine on our stream. Yeah, it dropped out completely maybe an hour ago or so. And it's spotty at best now, so hopefully the stream is going fine. Anyway, Java has static typing, so every type safety can be verified at runtime or at compile time. That's different from, say, C. In C, if you called quicksort on an array of integers and gave it a comparator for doubles, what would likely happen? This is backwards, right? These types don't match. Integers, doubles, they don't match. So what's going to happen? Probably a segmentation fault, right? What about Python? If you tried to use sort, you want to sort a bunch of students, but then you specified a key that was I don't know, something that's not a student, a balance. Does that make any sense? Does a student have a balance? Not in the sense that we've thought about it, right? So that would probably also fail. But both of those would fail at runtime. Here in Java, we have static typing, so we have safety. So for example, let's come over here and demonstrate this. What if I have a list of integers, numbers, is equal to, let's see, arrays.asList. This is just a really quick way of building a list. There we go. One. There we go. And I want a comparator for numbers. Comparator for integers. Oops. Integer. CMP. I'll just go with a, I don't know, comparator dot comparing, and then here's another way of doing it. X and Y. X is less than X minus Y. I think that this will work. Nope, darn it. I can't do it that way. Change to comparing, all right, fine. We'll do it the traditional way. New comparator for integers, and define it. So this is going to have a compare to method, right, or compare method, O1 to O2, and I simply just go ahead and say O2 dot compare to O1. I'm going in descending order here, right? Return this. And then I can go ahead and say collections dot sort numbers using that comparator and print them out. And this is numbers. There we go. Collections dot sort. So because of the way that I define this, collections, come on. Oh, forgot my semicolon. Now, because of the way I define this is going to sort in descending order, and I probably need to import this. Okay, fine. There we go. And let's actually verify this. 9754321 works, right? But what if instead I had a comparator for strings? Comparator for strings, CMP2, and it's for strings. And then I say string O1 compare to O2. You can do that. You can create another comparator. But what if I try to mix them? What if I say collections.sort numbers, but using CMP2? It's not going to compile. Why? This is a list of what? Integers. And this is a comparator for strings. Because we have static typing, this kind of polymorphic behavior can be checked at runtime, or at compile time. Now let's get in our time machine and go back 20 years, right? Where Java did not have these parameterized types. In 1998 Java, you had to do something like this. Get rid of that, get rid of that, get rid of that, get rid of that. There we go. And this is going to be object, and this is going to be object. There we go. And I can no longer use that compare to method because I don't know what these things are anymore. I don't know that they're integers. So what I'm going to have to do is I'm going to have to say integer a is equal to integer O1. There we go. Does this look familiar? This pattern, I should say. Does this pattern look familiar? Return a dot compare to b. Where I'm given these generic things, right, objects, and I have to force them to become an integer so that I can actually compare them. Look at their values, less than, greater than, equal to. Does that pattern look familiar? Where have we seen that before? Qsort. Qsort takes what? Or what a comparator for Qsort takes what? Hopefully we remember this. Right? Comparators for Qsort. What would they look like? Int, CMP, and then do they take integers A and B? Nope, that's not generic. Right? What would they take instead? Const void pointers. Right? Const, just because we're going to make a guarantee that we're not going to change it. Const void star b. Right? Then what would you have to do in that comparator? You would have to forcibly make them into integers or doubles or strings or whatever so that you can compare them. That's what 1998 Java looked like. Right? And let's do the same thing down here. This is no longer a comparator for strings. And I have to do the same thing here. This is now a raw, we call these raw types. These are just objects now. And I have to follow the same pattern. Where string, 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 and string. And now they become comparable. Witness what happened on line 37. I'm still comparing, I want to sort a list of numbers and use a comparator for what? What is that a comparator? You know, you as humans can see that this is a comparator for what? Strings. But as a dumb compiler, can it see that it's a comparator for strings? Nope. We're now back in the C world, right? Where we're using basically const void star, right? Raw types to do all this stuff. Let's run this and find out what happens. What do you think? Before I do that, what do you think is going to happen? Say what? It could be, so it's using a comparator for strings, so it's going to want to treat them as strings. But can you force an integer to become a string? Not really. Right? Class cast exception. The integer cannot be casted to a string. Right? But we lost all that information because we don't have proper polymorphism. Same thing would happen in Python, by the way, because there's no type safety. There's no static typing. If you gave it a list of student objects and you said that you wanted to sort it by balance, like I said before, or you want to transform those into integers so that you can compare them that way, that's not going to work either. So the smart people came along and said, we need type safety here. We don't want to live in a world where we have to just cross our fingers and hope it works. So they introduced polymorphism. And in this case, it's a parameterized polymorphism. We're going to go ahead and say that this is, if you spell it right, that this is a list of integers. Therefore, this is a comparator for integers. Right? Raw type, there we go. And therefore, this compare method, it has to be for integers. Right? Otherwise, it won't compile. It will not accept an object here and an object there. It has to accept exactly what you parameterize it to be up here. Right? That's a world that I'd prefer to live in, right? That's a world with good polymorphism. And it pops up over and over and over again. Right? First of all, subtype polymorphism. Right? So when you use inheritance, this is usually what we mean by polymorphism. When you use inheritance, you can treat a subclass as a superclass. Do you remember what we called that? There's a covariant, contravariant, invariant relationship. Do I have that up? Here we go. So treating a robin like a bird, that's always safe. Why? Because that's covariance. Contravariance is hardly ever safe. Invariance is never safe. But covariance is always safe. Right? Covariance is always safe. Right? This allows you to treat specific types as general types to simplify code. One example, you only need one list of, say, accounts to keep track of all accounts. Right? We did this before, right? And I renamed it into, what is it, account demo over here? There we go. We started out with two lists. One list for savings accounts, one list for annuity accounts. And then we had to add it up for this one. We had to add it up for that one. If I created yet another list of stocks or yet another list of checking accounts or something like that, I would have to repeat myself over and over and over again. 4 lists, 5 lists, 6 lists for each type, one for each type. I didn't do that. I used subtype polymorphism, and I created one list that was for any account. That allows me to put in a savings account. That allows me to add in an annuity account, because I'm treating the subtypes as their supertypes. It also allowed me to iterate over all of them and use a common interface to simply get all the values of them. Right? Without that, I would have to maintain a bunch of different lists. Right? Here's another example from the bird example. Right? So if I've got bird is equal to new robin, if I treat that robin as a bird, that's safe because it's covariance. And, integers, right? That doesn't work, right? We've got a list, integer, I erased the wrong thing, there we go. Integers, numbers, we're using subtype polymorphism here. If you, here's another example, it's not something you'd want to do in generally, but what if I just wanted to hold any type of number whatsoever? I had a bunch of integers, int x is equal to 42, int y is equal to 101, double z is, or a is equal to 3.5 and double b is equal to 10.5. Right? What if I wanted to treat all of those as the same? Now, the way that we've been using this up till now is a list of integers, integer, or a list of doubles, right? Or a list of, what do we call both of these things? Numbers. Right? So, sum numbers is equal to new array list. There we go. And I can say sum numbers dot add x, and guess what? Sum numbers dot add y will also work because they're both integers. An integer is a what? A number. And what is a double? A double is also a number. Right? So there is, we haven't talked about number here, but all number types, floats, shorts, ints, and doubles are all number types. And it's an abstract class here. Right? And it has no superclass, even though everything inherits automatically from an object. Right? So you could do something like this if you wanted to mix around doubles and integers into one list so that you can add them all up or something like that. There's a better way of doing this, though. Here's a preview. What type is that? T. Is that any type you've heard of? Nope. That's a generic type. So to understand this, and this is something that we'll look at on Friday, int x is equal to 42, double y is equal to 3.5. Both of these are variables. There's a variable called x, and there's a variable called y. But their types are fixed. What is the type of x? An integer. What is the type of y? A double. And no way are they ever going to change. I hesitate to show this to you. I showed it in the other, but I'll show it to you because I showed it in the other class. This is a newer feature that was added in newer Java in the last 5-10 years. Don't use it. Var z. What type is z? It has no type yet. That's why it's not compiling. What if I said equal to hello? Now can you tell me what type z is? Yep. What type is it? It's a string, right? This var keyword is short for variable, variable type. And you have to immediately, or at least at some point, assign it a value, at which point the compiler can say, oh, you assign z a value of hello, therefore, okay, I'll go ahead and fill in that blank for you. Wow. I saved on typing by 3 characters, didn't I? So this is why I'm mocking this, this feature of Java. It was adopted from C#. Why would you do something like this? It's not saving you any typing, right? And if you leave it like this and then 1,000 lines of code later, you finally then set it to hello, right? Same behavior, but is it at all clear? There are ways that you can do this, but is it at all clear what this variable is? Nope, right? So you've sacrificed clarity to save on typing of 3 characters. Don't do that. Here's how you should do polymorphic variables. T, z. Now z is a variable. It can hold a value. That value can be changed. But what type is it? Now again, it's not compiling yet. We'll solve that on Friday. What type is t, or what type is z? Sky's the limit. It can be anything, right? It can be anything it can, that you want, right? This is a parameterization. T is short for type, right? You could say type like this, right? But people don't usually do that, right? Let's take a look at the list class really quickly. List. I'm just going to go ahead and jump to it. There's a parameterization. Now in this case, E is short for element. It doesn't matter. They could have gone element, all caps. They could have gone element lowercase, but don't do that. They follow this pattern of using single capital letters to indicate the type. So what is this a list for? Is this a list for integers? Is this a list of doubles? Is this a list of strings? It can be anything because of this parameterization, because of polymorphism, right? So the first type of polymorphism is subtype polymorphism. This type of polymorphism is what's called parameterized polymorphism, and everything in between is what we're going to talk about today. Function or method overloading is another example, right? Overloading, right? This is not to be confused with overriding, writing, right? Overriding happens with inheritance in a subclass, right? That override annotation, where you've got a function and there's an at override that's automatically put in there. That's overriding. This is function overloading. When overloading does not involve inheritance. Instead, it involves functions with the same name. A function or method is overloaded if you have multiple functions of the same name, but different type or arity, that is number of parameters. Right. Again, we're dropping out again, but it's only 0.8% according to this. All right, good. So for example, C has no function overloading. Right. As a consequence, right. Tell me about the absolute value functions in C. What are, is there only one absolute value function? Nope, there's what? Abs. That works on what? Integers, right? So you'll lose precision if you try to take the absolute value of negative 3.5. It'll give you 3, right? So what do you need to use for floating point numbers? Abs, right? What do you need to use for longs? Labs. What do you need to use for longs? Well, labs, right? Et cetera, et cetera, et cetera, right? You are forced to create multiple functions with the same basic functionality, but with different names. Why? Because you're polluting the namespace. Because you don't have function overloading. Function overloading allows you to define multiple functions with the same name as long as there are different parameter types. So this is solved in a programming language like, say, C. Oops. Or not C, Java. Java solves this. Solves this by allowing you to define multiple functions with the same name. Now again, same example here. How many absolute value functions are there? Let's go ahead and close this. Let's go ahead and create a variable here. Int x is equal to negative 3. Double y is equal to negative 3.5. And I'll go ahead and take the absolute values of these things. Math.absolute value of x. Right. Now I'm not going I don't care about capturing the absolute value. I just care about this one function. Let's go ahead and jump to it. There's a function called abs, and it takes an integer. Let's go back to demo over here and change it so that I'll now pass in y. Guess what? That's a different function. That's the absolute value function, abs, that takes a double. Right? Float. Abs exact, don't worry about that. Long, right? We've got at least 4 or 5 absolute value functions here with the same basic functionality, but it takes different types. How did it know which type I meant? How did it know which one I meant? So when you pass in x here, what type is x? Now I'm a dumb compiler. I'm looking at this and I'm seeing, okay, x. What type is x again? We've got strong static typing, or static typing at least. What do? I go up to the declaration and I see, oh, it's an integer. Therefore, you meant to call this version of the function. Later on, if you go absolute value of y, right, then I say, okay, well, what is y? Y is a double. Therefore, you must have meant to call that version of the function right there. Oops, not that one. I didn't save, sorry. There we go. That version of the function. Right? They all live happily together in the same class. Abs for doubles, floats, longs, and integers. Somewhere in there. Right? That's called static dispatch. There are 4 absolute value functions, right, that each take a different type. But you have the same name. This is because the function abs has been overloaded. Right? The idea of overloading here is if you're carrying something, right? Oh, can you carry this too? Can you carry this too? Can you carry this too? You're overloading it, right? You're doing too much. That's how I look at it, but it's not doing too much because it's taking, the way that I look at it is the compiler takes on more responsibilities because it says, which function did you actually mean to call? Oh, you're passing in an integer, you meant to call that one, right? You meant to call that one, you meant to call that one. The compiler takes care of all that. The compiler is responsible for determining which function gets called or invoked based on the type of variable you provide. Right? This is known as static dispatch. Right? Why static? Static refers to at compile time, right? And dispatch, well, that refers to dispatch. What is dispatching somebody? Right? You get a call. I need a pizza at 542 A Street. Well, what do? You dispatch a driver to go deliver it, right? We've got something else at 123 B Street, right? You dispatch a driver to go and take care of it. The compiler is dispatching which function call you're actually making, right? So if you call absolute value, it says, okay, well, which one do you mean to call? I'll dispatch you to this actual function over here. Or I'll dispatch you to that function over there, or that one over there, or that one over there. Right? And it's done at compile time because it's done by the compiler. Who would have thought? Right? As long as the number or the arity or the type of parameter is different, you can have as many functions with the same name in the same class as you want. Right? And you'll see this in lab 6 tomorrow, or labs not tomorrow, a week from today. Right? You can also do this with with operators. Right? So, in Java, let's go ahead and take a look at what if I've got a string plus string. Right? Plus means what? Versus an integer plus an integer. Plus means what? And finally, a string plus an integer. Plus means what? So fill in those blanks. If I've got a string and I add a string using that plus operator, what does that mean? Concatenation. Right? What if it's an integer plus an integer? Addition. What if it's a string plus an integer? Change the int to a string representation and concatenate. Right? What about in Python? Oops, Python. There we go. What if I had a string, and I'll go with lowercase here, plus a string? What does that mean? Concatenation. What if I had an integer plus an integer? Addition. Right? What if I had an int plus a string? You remember what happened then? Or string plus an integer, it doesn't matter, it's commutative. No? Error. Right? You can't do that. You have to explicitly take that integer and wrap it up into you must do str of int plus string. You can do something like that, right? And that's not real Python, but you understand what I'm talking about there. You have to wrap it up into an str call, right? Why? Because it only has limited operator overloading. Operator overloading means giving more than one meaning to an operator in a programming language. Right? Other programming languages, like if you did this in PHP, it's something completely different. What it would be is, let's see, it would try to parse this integer as it would try to parse the string as an integer so that it could add it to the other integer. Right? Weird, right? And if it failed, then it would end up with 0, and you would never know about it. Right? So everything basically fails silently, right? Python. What about C++? Nobody really has any C++ experience unless we do. C++, right? You can do anything you want with anything. All right? You can, it's the Wild West. All right? You can take that plus operator and you can apply it to lists. You can apply it to a graph. You could apply it to a student, right? You could do things like this. a list plus a list. Let's just do it like this in C++. How would you interpret that? What's a reasonable interpretation of a list plus a list? If I would say, I don't know, 1, 2, 3, 1, 2, 3, plus 4, 5, 6 as lists. What if it looked something like this? What would you expect the result to be? 1, 2, 3, 4, 5, 6. So you would interpret it as append. Okay, that's reasonable. Is there another reasonable interpretation? Oh, okay. Why? We've got a 5, 7, and what? 9? There we go. We'll do it like that. So you're a mathematician. Who said that? All right, you're a mathematician, aren't you? Why? Because that is vector addition. Right? Component-wise addition. Right? Is there another one? You're all taking 235 right now, right? What could you do with one collection and add another collection? What is that called? Union, right? The U or the or intersection maybe, etc. Right? Way too confusing. Right? Because you can also do things like this. What does it mean to have time plus time? What if I said 12:01 p.m. plus 5 p.m.? Does that make any sense? No, I mean, you could interpret that as, well, 5 hours after. No, you started out at 12 and then plus 5, that's 17. And it's just because I used 12 that it ends up being the same exact time, but 5 p.m., right? It could be like 3 p.m. plus 2 p.m. Is that 5 p.m.? Right? It doesn't make any sense. So, right. What is graph plus graph? Maybe a union as well, but a union of vertices? Of edges? Of what? I don't know. What about student? You know, you can get really crazy here. Student plus student. What is that? Right? So, no, these are extremely ill-defined. Extremely ill-defined for all but the most obvious types. Right? Strings, integers, or strings and numbers, etc. Right? So, as a consequence, Java does not does have limited built-in function operator overloading, like the plus, right? But does not allow you to define user-defined overloading, operator overloading, I should say. In fact, the only programming language that I know of that does this is C++. Right? Most other languages take this ability to do something wacky and crazy like this away from you and not allow you to do something like this. You can do it with in C++. You can redefine plus for integers to mean minus. Right? You can do that, right? And you wouldn't want to do that, but you can, right? Because it is a language that just, again, it's the wild, wild west. Anything goes, right? So you can do whatever you want with anything that you want, right? And it's not good. Why? Because when you start doing things like this, okay, well, append is a reasonable interpretation, but this is also a reasonable interpretation. So is this. Which one is it? Right? Then you get into things like, there's no reasonable interpretation here at all with student plus student. Right? Extremely ill-defined. Avoid it. Right? So Java does not allow it. Most programming languages do not allow it, but it is a thing that you should understand and realize. Right? Last one is parameterized polymorphism. Polymorphism. Right? So again, Java allows you to parameterize classes, methods, or variables. Right? Now, we're going to do a full demonstration on Friday. What I want to do with the rest of our time today here is to really drive home the point of why this stuff is useful by going through an exercise that sometimes we do it in 155H, sometimes we don't. I don't think we did it this year. I've got a list of, say, integers. Right? Foo is equal to, I shouldn't have gotten rid of it. What is it? arrays.asList. Just some random integers here. There we go. 1. All right. To do, find the maximum value in foo. ... So let's write a function to do that. Public, static. What should it return? An int, okay. And it should return an integer because, you know, if you have an array of integers, the maximum value is going to be a double, or is going to be an integer. You already see where I'm going with this. Get max. All right. And we'll take a list of integers. Integer values. All right. There we go. What are you griping about? Add return statement. All right, fine. That's all. Help me out. How would you go about doing this? Int max value is equal to something, right? And then for each value in, or each integer, which is your x, in values, if x is greater than, x is greater than the max value that we found so far, update the max value to be x. And then finally return max value. So here's a good question. What should I set it to initially? Say what? Okay, negative infinity. How do I type infinity? 8 and then move my monitor sideways. Oh, what if I just assume that, oh, a 0? Is that going to work? No, why? You could have all negative values, or the maximum value, all of them could be negative values, right? Might not even be in there. Okay, well, I'll just make it, this is what we saw, unfortunately, on some of the submissions for the first assignment. Something like this. I'll just make it really, really big, right? And then they got away with it because we didn't have really, really big negative values, right? And, oh, it failed. I'll just make it bigger. Oh, it failed again. I'll just make it bigger. Right? Don't do that. Integer dot min value. There we go. Anything is going to be larger than that. Right? Good. You can go integer dot. Isn't there a infinity? Oh, okay. Double dot. Is there infinity? There's a nan. Oh, okay. Something like that. I don't want to get into that. Integer dot min value, or max value. Min value. There we go. All right. Now, anything that you find in that list is guaranteed to be at least as big as that thing. Okay. That will work. Let's find out if it does work. Int x is equal to get max of foo. And let's print it out. System.out.println x. So what's the maximum value in there? 9? Yay, it worked. And now somebody comes along and says foo is not enough. You also have a bar. And you have doubles. 0.1, 0.4, 0.0, 0.8, 9.1. Let's change that to 9.9 to make sure it works. And 1.2. There we go. All right. Is this going to work for bar? Int y is equal to that of y. Now, wait a second. We just got done talking about function overloading, right? Where you can have same function with multiple functions with the same name, right? But why isn't it figuring that out? Do I have multiple functions with the same name? Different parameters? No. That's easily solved. Copy, paste, done. Except change it to doubles. Right? And what should I return here now? A double. Right? And it's no longer going to be integer min value, double min value. Double what? Yeah, it should be a min value right there. Why aren't you? Oh, because I didn't change this. Sorry. Double. There we go. And double. And good. All right, and then we return max value. Oh, why are you still complaining? Erasure of is the same as another. Okay, yeah. Why are you not allowing me to do this? Ratio of method get is the same as another method. All right, fine. I'll put you somewhere else. Let's go up to a different class and just put it somewhere else. I don't know, account demo here. Account. I thought I had account. Oh, here it is. Account demo. I'll put it up here over here. There you go. And then instead of calling it demo, I'll say account demo.getMax. Oops, double. There we go. Actually, I should be able to do that now. That was my error. Right? Why are you not allowing me to do this? All right, fine. I won't do it like that. All right. What was the maximum value? 9 and what? 9.9. We're all good now. Right. So that value, that version and that version. What are the differences? Let's put them side by side. Get max and get max. What are the differences? Return type, parameterization type, that variable type right there, right? That type, right? That type. But what about the actual logic of the function? Is there any difference there? No. So let's rethink this. Right. I'm going to go ahead and have both of these in here. It's not going to compile, but we won't worry about that just now. There we go, and put it over here. All right. So how can I get rid of the duplication by saying that it's going to be the same thing for integers, it's going to be the same thing for doubles? Well, what's the trick that I just introduced? An integer is a what? A number. A double is a what? A number. So let's go ahead and change this initially to a number. There we go. And get rid of this. What are we going to have to change here? The values are a number, so it's no longer an integer number. Max value is no longer a number, or an integer necessarily. It's a number. And I can't use this built-in comparator here because that is only for the built-in types. Double, integer, float, and long. And short, I think. Right. But what I can do is I can say, well, what about my number here? Number x versus max value, right? X dot double value, if that is greater than max value dot double value, then I can do the same exact trick. All I'm doing here is converting this number into a double. If it were an integer, it'd be 9. It'd be changed to 9.0. If it were a double, then it'd be 9.9. It'd just change into 9.9. Right? So I'm converting it to the most general generic type here so that I can make this comparison. Right? And return not the integer, but a number. There we go. Now down here, if I change this to a generic number and a generic number, there we go. And I can go ahead and do this and this. There. Right. That's ideal. Right. Are you going to start? Why are you complaining because it's not parameterized yet? An integer is a double. Why are you not? All right, fine. All right. So here, I'll explain it now because we've only got 5 minutes left. It's complaining about these two things because one of them is expecting, I need to pass, I've got a list of integers here. Normally it would have to say that, well, it's a list of integers, it's also a list of numbers, right? But this is a list of doubles, which should also be a list of doubles. The reason it's not compiling is because it's way too specific it's way too general up here. It's saying that I need a list of numbers, not just a list of integers, not just a list of doubles, but I need to guarantee on this that this is a list of numbers. And so what I do is I need to parameterize this. T extends numbers. And I'm going to put T, I think you put T in front here. There we go. And oops, darn it, I forget my T. Oh, I need to put it over there, sorry. It goes over here. There, now it's fine. And it compiles down here. Let me explain what I just did there. what I did is I replaced the return, I put in a parameterization. I'm saying that this get max function is going to apply to any type t, right? I could do it like this, but do you have any information about t? Is it an integer? Is it a double? Is it a string? You don't have any information here at all. So I need to give it at least a little bit of information. I need to say that t is going to be a subtype of number. T extends number. So now, t, is it an integer? Well, if it's an integer, does integer extend number? Yeah, as we saw before. Is it, if t is a double, does that extend number? Yes, as we did before. So what about a string, though? Does a string extend number? No, so this would not be applicable to that type string. So by parameterizing this, I'm saying that, look, I'm going to give you a list of elements of type t, but that type t is going to be a subclass of number, which could be an integer, it could be a double, it could be a float, it could be anything. It just can't be a string. It can't be a student. It can't be something that is not already a number, that doesn't follow that is a relationship. Look at the beauty of that down here. Did I have to write two get max functions? Nope. I generalized them to any number whatsoever. All right? Well, let's go ahead and create one more list here before we go back, adjourn. Foo, bar. What comes after foo and bar? Oh, we don't know. Baz? What comes after Baz? I don't know. Don't ask me. And then let's go with Alice, Bob, and me, Chris. There we go. So is there a concept of maximum string? Yeah. Which one would it be in this case? Or here, let me put one more in here to make it 100% obvious. What's the maximum string here? Zoe, right? The one that would come at the end if it were sorted. Gee, I'd really like to do something like this. String z is equal to get max of Baz, and then print out z. Now, am I going to be able to do that? No, why? Is a string a number? Nope. So, I'm going to have to make this even more general. Right? What could I say that it's a minimum interface of in order to make, say, that this thing and this thing, I can compare these two things together. So if two things can be compared together, they are comparable. And now it works for, and I've got some additional things to take care of, but otherwise I'll be able to use this now. Right? Once I get this compiling and no longer treat these as numbers, that's where we'll pick it up on Friday. But I can do I can write this one get max function and never have to worry about this again for the rest of my life. Guess what? Somebody else thought of the same thing. Collections dot max. Right? It's already done. And it takes any collection, not just lists. It can take sets. It can take whatever. That's our ultimate goal, to reproduce this functionality right here. We still have some work to do because, again, what is this good for? It's only good for lists. All right, we'll change that into a set. Oh, we don't want to duplicate that code, so we'll generalize that even further. Right? And this gets into something called PECs, not like pectoral muscles, but PECs, producer extends consumer super. Right? Java generics. Producer extends consumer super. Basically, what we're going to ultimately do with this demonstration is we're going to make sure that we make things as general as possible, as generic as possible, until we get to a point where, oops, I've lost all the information I need. Let's go ahead and bring it back down, right? Until, oh, oops, now it doesn't apply to that type over there that I want to. So we'll find a happy medium here of absolutely general, like you have in C, right? Up here, let's go, where's the polymorphism in C, right? Where, do you have any information about this at all? No. That's way too general. Versus in C, if you had Q sort for integers, Q sort for doubles, Q sort for whatever. That's way too specific because that forces you to reproduce all this code. If there's a happy, healthy medium in there somewhere, that's our ultimate goal. And that's what PECs tells us to do. Producer extends consumer super. All right. We'll do that on Friday.